Hi, this is Dr. Gulshan S, your physics and math tutor. This is a question on interference in thin films. An oil film, refractive index 1.42, floating on water is 84.8 nanometer thick. What is the wavelength in nanometers of the brightest m is equal to 1 reflected color? Here, the answer has to be nanometers. So let's assume that there is a ray coming from here and is incident in angle I and gets reflected at the same angle I, and then another component of it enters into the oil film, gets refracted at angle R, and then gets reflected again from the water surface, and then goes in this direction. And finally, the ray number 2 comes here. So ray number 1 and 2 and all subsequent rays interfere, and this causes constructive or destructive interference. If it is constructive interference, you'll get a bright color. If it is destructive interference, you'll get a absence of that color. So if you look at the formula for this interference, there is a reflection from a denser surface, that is the oil top of the oil film, and there is another reflection from the bottom of the oil film, which has water on the other side, which is denser than oil, because refractive index of water is more than 1.42, which is the refractive index of oil film. So here, the condition for maximum intensity, that is constructive interference, would be 2 mu t cos r equals lambda by 2. We have taken into account the phase change of pi occurring here and the phase change of pi occurring here. And therefore, the condition for maximum would be 2 mu t cos r equals lambda by 2. Here r is the angle of refraction, and for the sake of simplicity, I'm taking the incidence to be near normal so that the angle of incidence is 0, and therefore the angle of refraction is also 0, and cos r is 1. So if you plug in all these values, 2 times mu, that is 1.42, multiplied by the thickness of the film, which is 84.8 nanometers, cos r is substituted as 1 is equal to lambda by 2. So if you work out the value of lambda from here, that is a wavelength which will be first order reflected most, then that wavelength will be 474.88 nanometers. So this is the wavelength which will be the first order brightest color which will be reflected from this film. And this color will be close to violet or blue, because this is on the shortest side of the visible colors, visible wavelengths. So it is the blue or violet color which is reflected most in this particular case. So this is a simple case of interference in thin films when light is falling on the film near normal. And here we assume the light falling is white, and the color which is being reflected most is wavelength 474.80 nanometers. Thank you.